Hello, welcome back to our little corner on the web, where we go over math problems to hopefully encourage and nurture an interest in math. Today, we will go over questions 5 through 8 in part 2 of the 26 PMO qualifying stage. Question 5. Let R and S be the roots of the polynomial x squared plus 2x plus 3. The value of 1 all over r squared minus 1 plus the fraction 1 all over s squared minus 1 is among the choices. So what we'll do here, because we know some of the properties of some of the products of polynomial, of a quadratic, is to rewrite the expression that we're looking for. So combining them to be one rational expression, we have the numerator will be s squared minus 1 plus r squared minus 1 all over r squared s squared minus r squared minus s squared plus 1. Okay, that's just combining them into a common denominator by multiplying the two denominators together to make the denominator, combine denominator, and then appropriately multiplying the numerator. Okay, so by what we know on sum product of roots in a quadratic, we know that Rs, the product, is equal to 3, and R plus S, in this case, is negative B over A, or negative 2. We're looking for, we have terms that are squared, so let's square the sum. So we get R squared plus 2RS plus S squared equals 4. We know Rs is 3, so R squared plus S squared is equals to 4 minus 6, or negative 2. So here, the numerator is just negative 2 minus 1 minus 1. So that's equal to negative 4 in the numerator. R squared S squared is basically RS squared, so that's 9. And then we have we're going to subtract R squared plus S squared to that. So that's plus 2, and then plus 1 for the constant. So we have negative 4 over 12, or negative 1 over 3. So the answer is B. Okay. Moving to the next question. Okay, question 6. 8 people are to sit around a round table on equally spaced seats. 2 of the 8 people, Alice and Bob, insist on sitting next to each other. Meanwhile, another 2, Clara and Dan, insist on sitting opposite each other. How many ways are there to seat the 8 people? Rotations are considered equivalent. Okay, so since rotations are considered equivalent, Clara might seem to have 8 choices in seats. Dan will be defined to be across from Clara. But in reality, all those 8 choices are equivalent because rotations are equivalent. So in essence, Clara and Dan, there's only one way to actually put or seat Clara and Dan. Okay, and then there will be 6 seats left, right? Let's number them 1, 2, 3, 4, 5, and 6. So now let's try to deal with where to sit Alice and Bob. So Alice and Bob has to take, seats that are beside each other. So there's only actually 4 ways of doing that. Let me list it down. It's either seats 1 or 2, 2 or 3, 4 and 5, or 5 and 6. Right? So we have to pick one of these 4, and Alice and Bob can swap seats, right? Can be it can either be Alice Bob or Bob Alice. So to sit Alice and Bob, there's actually 8 choices, or 4 by 2 choices. Okay. And then there will be 4 people left, and that's the easy factorial, right? So that will be the 4 factorial. So in essence, that's 8 times 24, okay, which is 192. So there will be 192 ways to sit those 8 individuals, or the answer here is simply C, or choice C. Okay, moving to the next question. Okay, question 7. A finite sequence A1, A2, all the way through AN, with n greater than or equal to 3, is said to be strongly unimodal if there exists an integer k with 1 less than k and k is less than n, meaning k is between 1 and n, such that a sub 1 is greater than the succeeding a sub k's, but a sub k is greater than all the a sub n's that are after it. How many strongly unimodal sequences a sub 1 through a sub 26 are there, which are permutations of the set 1, 2, 3, all the way to 26? Okay. First, notice that the inequality chain that we have here basically implies that for any set, a sub k has to be the highest number, because both the numbers on the right of it and on the left of it are basically just going down. So meaning for whatever k we choose, a sub k has to be 26. Okay. K has to be 1 and n. So 26 will not be at the far right or far left of it. The only thing that remains basically is a partitioning problem. What do we choose to be on the right and what do we choose on the left? Once we've chosen what's on the right and what's on the left, then the arrangement on the right and the left are both defined because they have to be successively going smaller. Okay. So just for clarity, I'll go through it case by the first few cases one by one. So let's say we pick k equals 2. Okay. For k equals 2, we can only pick one number on the left of it. Okay, there's only one slot left. So there's 25 numbers left. So there's 25. Choose one way of choosing which numbers goes on the left, and everything else is predefined. Okay. For k equals 3, well, it's similar, but now we're choosing two numbers to put on the left, right? For k equals 4, we're choosing 3 numbers to put on the left, and then everything else is defined, whatever's on the right, and also the arrangement of what's on the right and left. So if we take that reasoning further, for k equals 25, then we have 25 choose 24 ways of choosing what's on the left. Okay. If you notice, hopefully this reminds some of you of the Pascal's triangle. 25 choose 1, 25 choose 2, 25 choose all the way to 24. It's almost a full line in the Pascal's triangle. Almost a full line of but it's missing 25 choose 0 and 25 choose 25, right? It's missing this the front and the back. Okay. But 25 choose 0 is just 1, and 25 choose 25 is just also 1. Okay. Note also that the sum of the elements of a line in the Pascal's triangle is actually equal to 2 to the n. So in this case, that whole line, the sum of that line should have been 2 to the 25, but we're missing the front and the back, so it's 2 to the 25 minus 2. So the answer here is A, 2 to the 25 minus 2. Okay, moving on to the next question. Question 8. A square of side length 1 and a rectangle of length 34 are inscribed in a semicircle as shown below. What is the area of the rectangle? Okay, so here we want the area of the rectangle. We have the area, we have the length of the base. So really, we're looking for whether we can find this height here. Okay, notice that it would be easy to find that height if we can find the radius of that circle. Okay, because now it will be 17 h, and it's just a Pythagorean with the radius. Okay, so is there an easy radius to be found? Well, actually there is, if you note this radius here. Okay, so that will be 1 squared plus 18 squared, meaning 17 from here, and then this one is equals to r squared. So r is just the square root of 325. Okay, 18 squared is 324 plus 1, 325. So now we can find h, because h squared plus 17 squared should be equal to r squared. So h squared is no more than 325 minus 289, or h is equals to 36, or h squared is equal to 36, or h equals 6. So therefore, the area we're looking for is no more than 6 by 34, okay, which is equal to 204. So the area of that rectangle here is 204. Okay. Hopefully you found these solutions to be useful and educational. If you did, do hit the like button and subscribe. Thank you for watching.